Hello and welcome to this screencast on vectors. Now I'm going to go straight ahead and just draw a set of axes. So hopefully you're familiar with these axes before. And this is two axes in two-dimensional space, and here's a horizontal axis as my x-axis, and I've labelled the vertical axis as my y-axis. Okay, and a vector is simply a geometric object in space that has magnitude and direction. So here I've drawn an arrow. So the magnitude is the length of my arrow, and the direction is denoted by the arrowhead. And I'm going to call this my vector A. Now notice I've underlined the name of my vector. This is standard notation when we're using handwriting. If I was typing, what we tend to do is put the name of the vector in bold. Okay, so that's my vector A. How is A described? Well, we use what's called a tuple. Okay, so in two-dimensional space, it's called a two-tuple. So I have two values, and the values are, in this case, the change, which is denoted by the Greek character delta, along the x direction, and the change in the y direction. So this is in two-dimensional space. This is an example of a two-tuple. Now, what is the value of delta x and delta y? Well, change along the x direction. So if I was just to draw or form a right angle triangle, okay, change along the x direction is the change here, the delta x. There's a difference between this point, and the change in the vertical direction along the y-axis is delta y. So that's change between this point and that point. Okay, so that's how we describe a vector in two-dimensional space. For most applications, we actually have vectors in three-dimensional space. So if I have another vector b, and this is in three-dimensional space, we have delta x, delta y, and we have delta z because we're looking along the third dimension. And that's an example of a three-tuple. Okay. Obviously, in n-dimensional space, you have an n-tuple, and therefore you have n values. So delta x, delta y, and whatever other dimensions you have. But for most applications, vectors in three-dimensional space are most common. Okay, so that's a vector. One final thing I'm going to mention is the idea of the magnitude. Now, the magnitude is basically the length. And what we do is we use a form, or extended form, of Pythagoras' theorem. So if I take my vector b, the magnitude is denoted by these double vertical lines either side of the vector name. Okay, and I have a square root, and this is just Pythagoras' theorem extended to the third dimension. Okay, so x squared plus y squared, and we have plus delta z squared. Okay, and that's the magnitude of the vector b. So for example, if I just use some values for b, so if b is a vector 1, 4, say 6, the magnitude of b is equal to the square root of 1 squared plus 4 squared plus 6 squared. Okay, now if we do the arithmetic, 1 squared is 1, 4 squared is 16, and 6 squared is 36. Okay, if we add all those together, we have 53. So the magnitude is the square root of 53. And I'm going to leave it in that form. Okay, so that was a brief introduction to vectors, many applications, especially in physics and also computer graphics. So hopefully you're happy with that now, and that's vectors.